In example 7, we are going to look at something called logarithmic differentiation. So this works really well here if you have messy products or quotients, or if you have a function to a function power. So if you've got f of x to the g of x power. So for example, something that looks like sine x to the x power, and you want to find the derivative of that function. So let's look at the example here. We've got y equals x minus 1 quantity squared over x to the fourth sine squared x. So if we wanted to do just a normal derivative here, we'd have a quotient rule. And then when we did derivative of the numerator, it'd be a power rule. And in derivative of the denominator, we have a product rule and a power rule. That sounded like a detention problem. So we want a better way to do problems like this, to take those derivatives. So logarithmic differentiation, what you do is you take the natural log of both sides and then you simplify using properties of logs. Then you take your derivative and then you solve for y prime. So let's try that out. So this first step here, we want to take natural log of both sides. So on the left, natural log of y is going to equal the natural log of our x minus 1 squared over x to the fourth sine squared. And then we've got a division here inside the log. And so that is going to equal subtraction outside. So we do the natural log of the top, which is x minus 1 squared, minus natural log of the bottom, x to the fourth sine squared x. And then in the x to the fourth sine squared x, that's a multiplication that's inside the log. So that's going to be addition outside. So this will be natural log x minus 1 squared minus natural log of x to the fourth plus natural log of sine squared x. And then all of those exponents there are inside exponents. They're exponents inside the log. They're not exponents of the whole expression. So this 2 will factor down, as will that 4 and the 2 on the sine squared. So this simplifies a little bit farther. This will be 2 natural log x minus 1 minus 4 ln x, and then plus 2 ln of sine x. And now that's as far as we can simplify with logs. So second step, we're going to go ahead and take derivatives on both sides. So the derivative with respect to x of ln of y is going to equal the derivative on that right-hand side, which is our 2 ln x minus 1 and minus 4 ln x and plus 2 ln of sine x. Now, remember that y is a function of x. Y is this function here. And remember, if you have a natural log of a function, g of x, and you take the derivative of that, you get g prime over g. So function's on the bottom, and then its derivative is on the top. So if you take the natural log of y and the derivative of that, your function goes on the bottom, y, and then y prime on the top. And then log of, now do derivative of the right-hand side. So the derivative of 2 ln x minus 1, so the constant we can factor out of the derivative. Derivative of ln x minus 1, that's the log of a function, so function goes on the bottom, x minus 1, derivative on the top, 1. And then derivative of ln x is 1 over x, so this would be minus 4 times 1 over x. and then derivative 2 ln of sine x. The 2 will factor out of the derivative, and this is log of a function. So for that derivative, function goes on the bottom, sine x. Its derivative cosine x goes on top. And now we want to solve for y prime. So third step is to solve for y prime. And here we've got y prime divided by y. So we just need to multiply both sides by y here, where y is the original function. So these will cancel, and you're left with just your y prime on the left-hand side. And on the right-hand side, let's multiply the 2 up on top. So we'll have 2 over x minus 1. And then 4 times 1 up on top, so minus 4 over x. And then plus 2. And then cosine x over sine x is cotangent x. And then that all gets multiplied by y, which is our original function here. So x minus 1 quantity squared over x to the 4th sine squared x. And there's our derivative. So that wasn't too bad as long as you use your properties of logarithms and simplify down your expression on the right-hand side. Because products and quotients and powers just turn into multiplications for the powers, and then additions and subtractions for the products and quotients. So pretty cool.